Okay, so this numerical test here, 12F, class 10 electricity, chapter 12. Okay, so these two here, 4 and 5 will do in this class. And next two numericals will do in the next class. Go to page 227 of your textbook. Before that, let us write down the formulas that we need to remember. Maybe we need a space, so let's just put it there. So the first formula that we are accustomed with this so far, current is equal to charge divided by time. And second one is potential difference is equal to work done by charge transferred, right? And the fourth one here, I think yes, Ohm's law, I think, if I'm not wrong. Yeah, sorry, 3 Ohm's law equation, which is nothing but V, potential difference, is equal to I into R, current into resistance. Then a fourth formula is specific resistance formula, that is resistance is equal to specific resistance rho into L by A. The fifth one is resistor connection in series. Then we use the formula total resistance Rs is R1 plus R2, etc. The sixth one is if it is parallel, the resistors are connected in parallel, then it's the reciprocal of the total. So 1 by Rp, which is the total, is equal to the sum of the reciprocal of the individual resistances, depending on how many are there. 1 by R1 plus 1 by R2, etc. Okay. 7th formula. So we will be needing more formulas today. The main power formulas are these. Okay, just memorize it for now. Power is equal to work by time, or it can also be energy by time, or even heat by time. Okay, heat by time, because all these three different expressions mean the same thing, only heat by time, because work is energy, energy is work, and energy and work are heat. They can be interchangeably used. So power equation, the main power equation is work by time, E by T, H by T. So next one, the next power equation is this: P is equal to V into I. So these are the famous power equation: E by T, V into I. Potential difference into current, that means P is equal to I square R. Second one, the famous equation is I square R. As we go into the chapter, we'll discuss how it is derived, but for now, you just memorize it. So square of current into resistance. Another formula for power. Another famous formula for power is I square by T. Okay, I square by T. Oh, sorry, V square by T. V square divided by T. So this is potential difference square and time. V square by, no, T should not be there in power equation, so P square, V square by R. Okay, so if you know this main power equation, E by T, V into I square R, V square by R, the next 11, 12, 13 are energy equations. Okay, energy means, let me just demarcate it slowly so that we can actually use space, because we are cramped for space a little bit here. So here, okay, let us go like this. 11 is the heat or work. You can also do like that: heat, energy, work, whatever. Okay, heat and energy. That means you can put W also. The formula for this is here. You can look here. E equal to, if you shift this T, you will go up and multiply T. So E is equal to P into T. So first energy equation is P into T, or PT, power into time. The next one, 12. Go to the next formula. E equal to P into T. Then here, since E, P equal to T, so H equal to E. Just think and understand. You can understand here. We won't do detail, but just try to understand. See here, P is here. The next formula, VI. So in place of this P here, you can put VI. current and potential difference. In place of this P, you put VI, and then here T. So the next energy equation is VIT. First, the energy equation P into T from here. If you shift this T, it will go to the numerator and multiply P. The 13th one connected to H equal to E equal to this one, the next I square R. So this P here, now this one, replace it by this one. Then this P replaced by I square R. Then here, this T, you just substitute it. So I square RT is the next energy equation. The last one here, 14th. So we're going to need these 14 formulas. So here again, H equal to E equal to P, this P here replaced by V square R, because P is V square by R. So in place of this square P's, you put V square by R. Then that means this T, so V square T divided by R. These are the 14 formulas we're going to need from now on, okay, in different sums. Just memorize it for now. This part no need to memorize. You can connect 11 to 14 with 7 to 10, okay. The rest are you're familiar already. So let us start. Question number 4. This is on page 227 in the box there, textbook. Go to page 227. Let me read the question for us. How can 3 resistors 2, 3 and 6 ohm be connected to give a total of 4 ohms? So first let us solve this one. 4 ohms. So let us, when you connect these 3, the total should come out 4 ohms. The first question. So the question is, how are you going to connect them? So let's do like this. Firstly, let the 3 ohm, the second one, and 6 ohm resistors be connected in parallel. Okay, so we have given 2, 3 and 6. So the 3 and the 6 out of the given one. So you can write here if you want. Given is 2 ohms, 3 ohms and 3 resistor wires, 6 ohms. So we have chosen these 2 connected in parallel. So let RP be their total resistance. Let us put like that. Then since we have connected in parallel these 2, so we have to use the parallel formula here. So reciprocal of the total, which is 1 by RP, will be reciprocal of the first one, 3 by 1, so 1 will go up and 3 ohms come down, and plus reciprocal of the second one. So we have to calculate and find the total when these 2 are in parallel. Okay, so here, simple case of solving it carefully. So LCM of 3 and 6 is 6 ohms. 3, 2, 2 ones are 2. 6 ones are 6, 1 ones are 1. So we're going to get here RP is equal to 3 by 6 ohms. Okay, and 3 2s are 6, that means 3 ones are 3. So cross multiply down and up. RP into 1 is RP only. Then equal, then 2 ones are up and down or down and up, 2 ohms. So let's put this one as 1. Now, then you say like it. Then let RP equal to 2 ohms, the ones we just got now, be connected with the one we have not yet used, this one, with the 2 ohm resistor in series. Let us do in series. So now these 2 combined give you a single value 2. Let this one be now connected to the one not yet involved in series. Then we will get 4 ohms. So we write here let RS be their total resistance this time. RS be their total resistance this time. So in this series, therefore series means series formula, RS is equal to First one is here, RP. The first one, RP, plus second one is here 2. So the one not yet connected. So when you do that, you're going to get RP equal to 2 ohms. So 2 ohms plus 2 ohms. And you write your since RP equal to 2 is given in using equation number 1. So the total of the whole system has come out 4 ohms. Correct to the question. So the 3 combined now. First it's 2 in parallel, and their parallel connection connected to this in series. Then we're getting the total of the whole system or circuit as 4, which is what the question is asking. Which means, what did we do? That is, we have connected like this. Let's go like this. Parallel means 1, 2 of them between the same 2 points. So this is point A, let us say, and this is point B. The 3 ohm, 6 ohm we connected in parallel means these two, their starting point is A of both these two, and the ending point of the two resistors is B. Same ending point, beginning point. If they're joined like that, that means that's parallel. Then after that, we connected their total. This two total is coming out 2, connected in series, which means after the ending point of these two combination, we have put the 2 ohm which was not yet connected in series. Then the total gave you battery, let us say, switch if you like to put. Then current will flow from positive to negative. So it flow like this. Then you're getting a total of 4 ohms. So to get, go back to question, to get a total resistance of 4 ohms, the 3 ohm and 6 ohm resistors has to be connected in parallel first. Let us put here full stop. Then continue from here. This in turn has to be, this is gate, okay, GET, connected in series with the 2 ohm resistor that is yet to be connected. Then when you do that, these two in parallel, which in turn connected to series with the one not yet connected, 2 ohm, then the total is giving you 4 ohms, which the question is asking us. So this is our answer. We solve it and then we write this final answer. Okay, so this is for A. Then let's go to B. So for B, same question, another one is there. This time, how do we get total resistance of 1 ohm? So we're given this, given are the 2 ohm, 3 ohm and 6 ohm resistors. These three are given to us. So how do we arrange them to get 1 ohm this time? The same set of resistors. So what is it? Let this 2 ohm, 3 ohm, 6 ohm resistors be connected in parallel, everything in parallel. Then we're going to get 1 ohm setting. So let RP be the total, RP be the total resistance, in this case. Okay, then parallel means that formula number 6, reciprocal of total, RP we have decided here. This is called reciprocal of first one. This is 2 ohm by 1, so reciprocal is 1 will go out, so reciprocal is 1 by 2 ohm plus reciprocal of the second one plus reciprocal of the third one. Then we're going to get the formula for, this is the formula for parallel circuit. So Rp equal to LCM of 236 is 6 ohms, 2 3 3 1, 3 2s are 6, 2 1s are 2, 6 1 1 1. So you're going to get your 1 by Rp equal to 6 here. So 6 by 6 ohms cancel means 1 is left. Rp into 1 is Rp, and 1 into ohms is 1 into 1 ohm is 1 ohm only, cross multiply. See, now the total is coming out exactly what we require. So we have to draw, let's just draw the diagram. That is, we have to connect like this. This first one 2, then the second one 3, and the third one like this in parallel, meaning all the 3 points have same beginning point A, ending point B. First resistor 2 ohm, 3 ohm, and all the beginning point of these are here A, the ending point of all these three are same, B means parallel, connected to a battery switch, and if you switch on, then current flow from positive towards negative. That's how we do it. So this is the required connection. This is how we have to connect. So you can write here, that is, so to get total of or total resistance, as the question is requiring us to do, resistance of 1 ohm as it is here, we the 2 ohm comma 3 ohm comma 6 ohm, the three resistors has to be connected in parallel. Then we are getting exactly a total of 1 ohm. Why did we do parallel? Because we know that all these are small, bigger than 1, and we know that when we connect in parallel, the total comes out always lesser than the least. The least among these three is 2. Their total is going to be less than 2, also the smallest one. When we do in parallel, we know that in the previous numericals also we have discussed that, right? So intentionally we have chosen parallel because 1 is lower than all the 3, right? Okay, and then in the previous one 2 3 6, and A was total need to be 4, which is not the lowest also, not the highest also, in middle. So we knew that 2 of them had to be in parallel and the other one in series. Then we're going to get somewhere in between. That's how we assess, and we're connecting it. Okay, so this is the one. Now let's go to the next question for this class. Question 5. So question number 5. This is on page 227 still, I think. Page 227. Let us see. Let me read the question. What is the highest A and the lowest total possible that can be secured by combination of the 4 resistant coils, 4, 8, 12, and 24? So let us start. Given 4 given resistor coils. You can just write like that, resistor coils, the one given to us. Let us say 4 ohms is given with 8 ohms wire, then 12 ohms and 24, 4 of them are given. Number A, the highest. So how can you get the highest? This is quite easy. I've told earlier class also, but let's repeat. Now when you want higher resistance, we do in series, because in series the total resistance will come out higher than the highest. What is the highest among this individual? Yes, that's right, 24. There is no other one greater than 24. So if you connect this in series, you're going to get a total more than the highest, which is more than 24. So the answer is in series. So let to get the highest resistance, as it is mentioned here, the 4 ohm, 8 ohms, 12 ohms and 24 ohms resistors or resistor coils has to be connected in series. Why? As I said, when you do in series, their total is going to be even higher than the highest, and there can be nothing higher than that. They are telling you how can you get the highest resistance possible by arranging this. How will you arrange this to get the highest? The arrangement is series. There can be no higher value than series. Okay, so here let us write here, let RS in this case be the total resistance. So let us see, therefore series means RS, this one say 5 equal to R1. First one is R1 is 4 ohms, second one is 8 ohms, then 12 ohms and 24 ohms. So if you add this, 36, 44, 48, so 48 ohms. This is the highest value you can get. So you write here, this is the highest required resistance, highest resistance that you can get. Highest resistance, the answer 48 ohms. Okay, then the lowest possible. So this is A. Okay, this is A. Then let's go to B. B is, go to textbook, the lowest resistance. So the lowest, how can you get lowest possible, lowest resistance value, which is 4 coils. So to get highest, we do in series. Now when you do in parallel, then answer this question, which is the smallest value resistance here? That's correct, 4, right? There's no one among this, 4 is the lowest. So when you connect all these 4 in parallel, you're going to get total even lesser than the least. I repeat, when you connect the given resistances in parallel, you get total higher than the highest. When you connect the same thing in parallel, you will get a total lesser than the lowest, which is, so the lowest possible will be parallel. So to get the lowest, by going by the same one, lowest resistance, that 4 resistance has to be connected in parallel. That's only difference. Then you will get the lowest value. Let RP this time be the total resistance. Write it down up to there. Then since it's in parallel now, reciprocal of total 1 by RP will be 1 by R1 is here 4 ohms, 1 by R2 is here 8 ohms, 1 by 12 ohms and 1 by 24 ohms, the 4 of them. Then we'll see that it's going to be even lower. This total RP is going to come out lower than 4. Just check. 1 by RP is equal to 24 is the LCM, because all these numbers are going with 24. 4 6 are 24, 6 1s are 6, 3s are 24, 8 1s are 3 1s are 3, 12 2s are 24, 2 1s are 2, 24 1s are 24, 1 1s are 1. So we're going to get 1 by RP equal to 6, 9, 10, 12. So 12 by 24 ohms. So 12 1s are 12, 12 2s are 24, let us say. Cross multiply, RP into 1 is RP, 2 1s are 2 ohms. So this is the lowest resistance possible. Means this value. So this is your answer, 2 ohms, which is lower than the lowest. You see, 4 is the lowest among the individuals. Now the total is even lower. So remember, when we want lowest resistance, we connect in parallel, because the total comes out lesser than least. When we want highest possible, we connect in series, because in series the total comes out higher than the highest. Okay, so we'll continue these 2 questions in the next class. So I hope you got it right.